Scientific notation, sometimes known as standard form. This is really helpful especially in science when you are doing large or small calculations in your labs and that kind of thing. So it's important that you know how to convert between both. So just to get started, evaluate each of the following. So all of these have base 10, and that's kind of the background of scientific notation, is they're all expressed as some power of 10. So that's 10 cubed, remember, is 1 with 3 zeros. 10 to the negative 3 is 1 over 1,000. And so as a decimal, that's 0.001. 10 to the 5th is 5 zeros, okay? Vice versa, express each of the following as a power with base 10. So 10 to the, remember, you count up how many zeros. So 3, 4, 5, 6, 7, 8. And here, it's going to be negative exponent, right? Negative made it positive there. So remember, this is going to be how many decimal places? 1, 2, 3, 4, 5. So negative 5, because that would be, remember, 1 over 100,000, which tells you that we need, the number of zeros tells you how many decimal places, 5 decimal places. So to evaluate, when we're dealing with numbers like this, remember this has 3, 6, 8 zeros, so we move the decimal 8 to the right. So 2, 6, 4 would be moving it 2 times. And so then we have to have 6 more times to the right and fill in with zeros. So there should be, where originally the decimal was after the 2, now that should be 8 place values according to the zeros. Here, dividing by 10,000, 2.64, so that would be 0 point, and then we're moving 4 decimals to the left. Okay, so we're really filling in with 3 zeros. So the decimal was there, 1, 2, 3, 4. Okay, based on the number of zeros. So now, basically, numbers like this, we want to show, we don't really, not that we don't care about the zeros, but a faster way of showing a number like this is to express the power of 10 just as that, a power of 10, either with a positive exponent or a negative. Negative exponent if it's a decimal, positive exponent if it's larger. Okay, so in scientific notation, also known as standard form, numbers are written in the form a times 10 to the n, where a is a number greater than or equal to 1, but less than 10. And a is, now it says here, a is a set of the natural numbers. Doesn't have to be, okay, because we could get numbers with decimals. So that actually, when we made up this form, that we need to be careful of that. So a could be any rational, real number, okay? It's going to be rounded. N, though, needs to be, so n is set of integers. Could be positive or negative. So your calculator will display very large or very small numbers in scientific notation in this form. So so some number, capital E to another number. You can't use that notation on a quiz or a test, and I'll show you that in a few minutes. So now it says express the following numbers in scientific notation. So our first number has to be between 1 and 10, or less than 10. So we always look to put the decimal to the right of the first non-zero digit. So going from the left, we've got a 4. So we put the decimal afterwards, copy every other non-zero number, okay? And then think about what the exponent on 10 has to be to represent moving that decimal place from there to where it is here. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 4.872 times 10 to the 9. If we do that, it moves the decimal 9 to the right. Okay, so that means there should be 9 digits here, 3, 6, 9, after the 4. Then, going from the left, we look for the first non-zero digit, put a decimal after, copy all the non-zeros after that, times 10 to the, and now we know it's going to be negative because this is a decimal less than 1. And so now we think about, okay, how many place values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So negative 11. Okay. Then vice versa, express in expanded form. So this is going to be 5 with 5 zeros, because we're moving the decimal 5 to the right. Here we're moving the decimal 7 to the left. So, so when you think about that, 7 to the left, there's 1. So there's got to be 6 more zeros before the decimal. So 1, 2, 3, 4, 5, 6, 7. So if we've got, I always like to put 0 decimal, that's proper form. And then if we're moving 7 to the left, we've got a 2 already in there, one of the 7 decimal places, so there's going to be 6 zeros, filling it in. And just check, right? 1, 2, 3, 4, 5, 6, 7. Sometimes you might miss a 0 for some reason. Okay. Express the following numbers in correct scientific notation. So notice how this is kind of looks like scientific notation, but it's not really, because this first number is not between 1 and 10. So we want to basically, you can show it in 2 steps. Take this and show it in scientific notation. So 2.5478 times 10 squared. And then we're multiplying that by 10 to the 6. So really, we're multiplying powers with the same base, which is 10 to the 8. Then here, this is going to be 3.6 times 10 to the 1, 2, 3, 4, negative 4 times 10 to the negative 2 is 3.6 times 10 to the negative 6. And you're just multiplying powers with the same base. Then next one, think about these as coefficients. So multiply 5.78. So 5.78 times 6.87. So I do this in 2 steps, 39.7086 times 10 to the 5 plus negative 16 is negative 11. And then this becomes 3.97086 times 10 to the negative 11, which is 3.97086 times 10 to, so that's a 1 there, right? 1 plus negative 11 is negative 10. So scientific notation, that number has to be between 1 and less than 10. And then here dividing, divide the coefficients. So 1.26 divided by 7.98. Now, it doesn't say what to round to. So this is what I get on my calculator. Okay, usually it'll tell you what to round to, but I'm going to keep it like that. And then here, simplifying the powers, that would be 10 to the 13. Okay, and then this isn't between 1 and 10. So I've got to go 1.57894736 times 10 to the negative 1 times 10 to the 13. And then simplify the powers. And then a little example here, find the volume of a computer chip, a cuboid that has these dimensions. So check they're all the same units. And if it's a cuboid, then you're multiplying. all of these together. So volume equals length times width times height. Okay, so we've got 2.44 times 10 to the negative 6, 1.5 times 10 to the negative 7, 2.15 times 10 to the negative 4. So take all of those coefficients, 2.44 times 1.5 times 2.15. Then your powers here, negative 6 plus negative 7 plus negative 4, that's negative 17. And you're done. And that would be meters cubed. Okay. If we take a look at our calculator, okay, so let's go back and do this product here. So you can put it in just like it has on paper. So times 10 to the 5th. Oops, got to out of the brackets. That's what you got to be careful of in the newer versions of this calculator. Okay. If you have an older version, then it won't be raised up like this. You'll see the actual kappa symbol. That's okay. Enter on that, and you'll notice it gives the scientific notation, but it doesn't say 10 to the negative 10. It says e to the negative 10. So capital E represents times 10 to that whatever exponent it is. Okay, so just be aware of that. As well, if you wanted to put in, so here on the division, be careful on this. If you use the multiplication like that, put brackets. So 1.26 times 10 to the exponent 18. Close the brackets before you divide. Open brackets, 7.98 times 10 to the exponent 5. Oops. Okay. If you have, so there you can see it. If you have a newer version like this calculator that I'm using, then you can go alpha y equals n over d, we'll put it in fraction form. So then you could go 1.26 times 10 to the 18, and you wouldn't need brackets. Cursor down, 7.98 times 10 to the exponent 5. Cursor out, enter, get the same thing. And then also, if you take a look at your calculator, you'll see on the, if you have a TI, on the comma, second feature is EE. So if I do this again, 1.26, if I go second EE, I don't know why it's EE, both double there and just one here, but EE means I would just, that takes care of times 10, and then I'd put in the 18. Okay, then down below 7.98, E5, same thing. Okay, so that's your calculator, and then I think we're done.